Welcome to Probability Video 6.1, combinations and coin tosses for this example. All right, so here's example 1. So you toss a coin 10 times. All right, and then we want to answer all these questions related to that. First, A, what are the number of total possible outcomes? All right, we're going to go back to the multiplication rule. Event 1 can be heads or tails. There's 2 ways of doing that event. Event 2 could be heads or tails, 2 ways of doing that event. And so on and so on and so on. So I'll just keep multiplying by 2. A shorthand notation would be 2 to the 10th. So equals 2 to the 10th. And you could use your fingers or your calculator, and you get 1,024. Okay, so there's 1,024 possible different ways to have outcomes. All right, part B. Now, again, we're tossing the coin 10 times. We want to know how many outcomes have exactly 5 heads. So they could be 5, in the row, it could be heads, tails, etc. So basically, out of these 10 slots, choose 5 of them to have heads. 10, choose 5. So it would simply be 10, choose 5. And if you punch it out, you get 252. Okay. Part C, at least 8 heads. So I underlined some of the important words here. So at least 8 heads means we could have 8 heads, or 9 heads, or 10 heads. All right, so I'm going to use this same principle over here. Well, to get exactly 8 heads would be 10 choose 8. Or means to add plus over here, 10 choose 9. Or means plus over here, 10 choose 10. And if you compute that, that's really a 45 plus a 10 plus a 1. And we get 56 as our answer. Okay, D. This one's going to be a recurring theme all probability unit. At least 1. So whenever we say at least one of an object, what we can do is draw a little set here. Again, we've done this before. I've got the total number of ways was 2 to the 10th equals 1,024. And I can split it up into 2 partitions. The ways with no heads, or the ways with at least 1 head. Again, either you're going to have at least 1 of something, or none of something. Either it's going to rain at least a little bit, or not at all. Okay, so it's easy for me to find this part, so I'll use subtraction like we did before. So at least 1 heads is the same as the total minus no heads. Okay, so at least 1 heads equals a total 1,024 minus no heads. No heads would be out of the 10 slots, choose 0. And of course, you should know there's only one way for that to happen, to have everything be tails. So it's going to be 1,024 minus 1 equals 1,023. And that's the answer for part D. Part E, kind of similar to this, except now we've got at least 3 heads. Okay, so for at least 3 heads, I could add up like I did over here, 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. I could have done that over here, 1 or 2, but that list is a little bit longer. So depending on which side of the midpoint I'm on, like about 5 heads, I decide to use this technique or not. All right, so what I'm going to do is say, if I got at least 3 heads, if I don't have at least 3 heads, I've got 0, 1, or 2. So I'll say at least 3 heads. I'll erase this to give myself some more room. equals total minus, now in this case, instead of no heads, it's going to be 0 heads or 1 heads or 2 heads. 0 heads plus 1 heads plus 2 heads. Okay, still fewer computations doing it this way as opposed to adding them all up. All right, so that's going to equal 1,024 minus 10 choose 0 plus 10 choose 1 plus 10 choose 2. All right, so it's going to be 1,024 minus 1 plus 10 plus, I've got it over here, 45. And if you compute that, you get 968. We'll just put it right here. And that's the answer to part E. Okay, last one. At most 1 heads. Okay, well at most 1 heads means 1 heads or fewer. Don't forget, there's always the possibility of 0. So at most 1 heads is the same as 0 heads plus 1 heads. All right, so again, just for 0 heads, out of the 10, choose 0 to be heads. For the 1 heads, out of the 10, choose 1 to be heads. So that's going to be 1 plus 10, and that would be 11. And again, with combinations, there's symmetry, as we learned in Pascal's triangles, so feel free to use whatever technique you want. So there you have it, how to use combinations in conjunction with coin tosses.